Assalamualaikum and salam sejahtera. So we are from the group 13 from the section 3 operational research are going to present a case study of Kopikhu Cafe. So without further ado, let's get to know the group members. Our team consists of 5 group members, which are the first one is Liao Yui, me myself Suraya, Ko Boyao, Nur Zubaida, and Aida Natasha. So before we start to share our findings, we really hope you have a great time and gain valuable insights from this study. So our group has chosen Kopikhu Cafe as our collaboration partner for this assignment. So a little bit about Kopikhu Cafe is like they are started as a home-based business called Ada Cookies back in 2020. And in November 22, they have opened a physical cafe in Batu Pahat, Johor, and have since expanded to include a bakery and a kiosk. So with a small team of 9, they have built a good reputation for their quality beverages and baked goods, and even earning a nomination for the 2025 Johor Best Food/Bakery Awards. However, as the cafe grows, they are facing challenges in improving their production process, especially in figuring out the right quantities of cakes and tarts to make while managing their limited time and resources. So our goal here is to help them solve this by creating an optimization model that determines the best production mix to maximize their profit. So without further ado, let's jump in.
Research design. Research design is a systematic plan, outlining procedure, data collection and analysis method. In this study, we use qualitative. Qualitative is a non-numerical data collection to understanding challenges. By using this method, we can identify optimum production quantity of cakes and tarts while considering the bake time, preparation time, and minimum production level to increase the profit. Data collection. In data collection, we use interview. One section interview was conducted with Ms. Kalisha, manager of Kopikhu Cafe, on 30th December 2024 at Batu Pahat. Data analysis. In data analysis, we use integer programming with the branch and bound method. The branch and bound method is to solve the optimization problem requiring integer solution by dividing the solution region into the subproblem. The outcome is to determine the optimum production mix of cakes and tarts while managing constraints like preparation time, bake time, and minimum production level to maximize the profit.
Kopikhu sells a few different bakeries like cakes, bread, tartlets, and cookies. The production process for cakes and tartlets is similar as both of the bakeries require preparation and baking time. In producing one batch of cakes, Kopikhu will prepare 2 pieces simultaneously. Each cake is equivalent to X slices and require 30 minutes to prepare and 60 minutes to bake. Meanwhile, one batch of 40 pieces of tartlets takes 30 minutes to prepare and 30 minutes to bake. During the current production period, 165 minutes in preparing pastry and 285 minutes in baking times are available. Each slice of cake sold yields a profit of 3 ringgit and each piece of tartlet sold for 50 cent profit. Therefore, Kopikhu intends to determine the possible combination of cakes and tartlets to bake to maximize profits. For step 1, we transform the data collected from Kopikhu's manager Ms. Kalisha into the objective function and constraint in performing the integer programming operation problem. For step 2, we need to look for the coordination for both linear functions, which are 30x plus 30y less than or equal to 165 and 60x plus 30y less than or equal to 285 to insert into the graph by substituting either x or y to 0 to get the opposite value. For example, we substitute x to 0 into 30x plus 30y less than or equal to 165 and get the y value 5.5. Then we get the first coordination, x equal to 0 and y equal to 5.5. Repeat the same step to complete all the coordination. In step 3, we draw the lower limit lines for both cakes and tartlets, which are x greater than or equal to 2 and y greater than or equal to 1 into the graph. After all the lines have been drawn, we need to highlight the feasible region by specifying all the constraints. After the quadrilateral shape is constructed, we need to look for the point in every corner. Point 1 and point 2 can easily be determined, but point 3 and point 4 require the use of elimination to look for the exact values. For example, we use both of the linear function to eliminate y and get both the values x equal to 4 and y equal to 1.5. Then for point 4, we use the function of 60x plus 30y less than or equal to 285 and y greater than or equal to 1 to look for the coordination x equal to 4.25 and y equal to 1. Next, step 4, after we compute all the exact coordination by using elimination, we have to look for the optimum profit by using the objective function, z equal to 3x plus 0.5y. For instance, in point 1, x equal to 2, y equal to 1, the profit is 6 ringgit and 50 cents. Moreover, the optimal solution is at point 4, x equal to 4.25 and y equal to 1, with a profit of 13 ringgit and 25 cents.
Okay, after we identify the optimal solution in step 4, we need to determine the upper bounding and lower bounding. Therefore, the optimal solution, x equal to 4.25, y equal to 1 with a profit of 13 ringgit and 25 cents, will be the upper bounding. We need to look for the lower bounding, as the graph shows the optimal non-integer solution. For the lower bounding, we have to round down the non-integer value, x equal to 4.25, by rounding down to x equal to 4, and y remains y equal to 1. Then we use the objective function, z equal to 3x plus 0.5y, by substituting x and y values to look for the profit, 12 ringgit and 50 cents. Furthermore, we use the optimal solution variables, x equal to 4.25 and y equal to 1, in performing the branch and bound method. Firstly, in subproblem A, we round down the non-integer value, x less than or equal to 4, and we get the value y less than or equal to 1.5. We use the objective function to look for the optimal solution, 12 ringgit and 75 cents, then the new feasible region is constructed. Subproblem B has no feasible solution region, as the line x greater than or equal to 5 is beyond the feasible region, and we need to terminate this branch. In addition, for subproblem C is the branching of subproblem A, we take the value x less than or equal to 4 as the line y less than or equal to 1 crosses with it. Also, we stopped it at this branch as the solution is integer and feasible. The optimal solution is 12 ringgit and 50 cents, and the lower bounding is met. Subproblem D's optimal solution is 11 ringgit and 50 cents, and x equal to 3.5, y equal to 2. A new feasible region is formed. Besides that, the optimal solution for subproblem E is 10 ringgit and 25 cents, and x equal to 3, y equal to 2.5. A new feasible region is constructed. For subproblem F, the intersection point for x greater than or equal to 4 and y greater than or equal to 2 is beyond the feasible region if the constraints x less than or equal to 4 and y greater than or equal to 2 are observed. Terminate this branch as it has no feasible region solution. Moreover, subproblem G has the integer solution as y less than or equal to 2 intercepts with x less than or equal to 3 if the previous constraints x less than or equal to 4, y greater than or equal to 2, and x less than or equal to 3 are observed. We stopped it at this branch, and the optimal solution for subproblem G is 10 ringgit and x equal to 3, y equal to 2. Lastly, for subproblem H is fatal, as this solution we found is way lower than we compute previously. Lower bounding is equal to 12 ringgit and 50 cents, and this optimal solution is only 9 ringgit, and x equal to 2.5, y equal to 3. Since subproblem C, G, and H have integer solutions, the optimal profit is subproblem C, which gives a profit of 12 ringgit and 50 cents that meets the lower bounding requirement. Therefore, Kopikhu needs to produce 4 pieces of cakes and 1 batch of tartlets daily to make profits of 12 ringgit and 50 cents.
To conclude, our group focused on optimizing Kopikhu cafe production processes to maximize production. Our analysis found that producing 4 cakes, 32 slices, and 1 batch of tartlets daily yields the highest profit of 12 and 50 cents ringgit. This study highlights the practical use of integer programming and the branch and bound method in addressing real-world operational challenges. This technique offers small business like Kopikhu Cafe an actionable solution to enhance decision-making and resource management. Our group recommends several steps to enhance Kopikhu Cafe's operation and profitability. First, improving operational efficiency through equipment upgrades. Streamline workflow and staff training can reduce preparation times and boost productivity. Second, diversifying product offerings such as seasonal baked goods and beverage can attract a broader customer base. Market research will ensure this addition meets customer demand. Third is adopting tools like production planning, software and inventory management system can improve demand forecasting, stock management, and resource allocation while saving time, reducing error. Finally, analyzing sales trends, customer behavior, and marketing effectiveness will provide valuable insight to refine operation and align with market demand.